There are a number of different factors that affect how fast a reaction happens. That is, factors that affect reaction rates. And those factors mostly come down to two considerations. Does the factor affect how quickly or how often or how easily the reactant molecules come together or collide? Or does it affect the speed at which those reactant molecules collide? The first factor that we'll consider is the physical state of the reactants, or the surface area of those reactants. They're not exactly the same thing, but they're definitely going to affect the reaction rate based on similar arguments. Reactants need to come together or collide in order to react with one another. And reactions where the reactants can easily interact are therefore more likely to happen quickly. So consider two different situations. You have a liquid reactant reacting with a liquid reactant. In this situation, you have two reactants. They're both in the liquid state, which means that all of the molecules can flow freely, they can move around, and the molecules of reactant A can interact with reactant B. With solids, so a solid reactant and a solid reactant, you have a somewhat different situation. In solids, the molecules are fixed in place, and it's much harder to make them move around. So you would have to physically move the reactants over one another. You'd have to mix the reactants together in order for the reaction to happen. So liquids reacting with liquids is going to be a much faster reaction, and solids with solids will be much slower. And we can generalize that to say gases are going to react more quickly than liquids, and liquids are going to react more quickly than solids. And by a related argument, we can consider surface area. So imagine you have two solid reactants. You have two solid reactants that are represented by these poorly drawn cubes. In order for them to interact, they have to come into contact with one another, and they have a limited amount of surface area with which to do so. But if you break these materials up into smaller pieces, you can see that they have much more surface area available to interact with. In the second example, the one below, you have the same amount of material, but it's been broken up into smaller pieces. And you can see that there's much more surface area, and that means that there are far more places where the two reactants can come into contact with one another, and therefore the rate will be increased when the surface area gets bigger. The way concentrations affect the rate of a reaction is fairly similar to the physical state or surface area. A higher concentration simply means that there's a higher likelihood of collisions between the reactants, and therefore a faster rate of reaction. Remember from learning about gases that the average particle kinetic energy is going to be directly proportional to temperature. A higher temperature means a higher average kinetic energy, which means that the particles are going to be colliding both with more force and likely more frequently, and therefore they're more likely to react. And because of this, an increase in temperature corresponds to an increase in rate. The final factor affecting reaction rates that we'll discuss is a catalyst. A catalyst is a type of material that takes part in a chemical reaction but doesn't actually get used up like one of the reactants. At the end of the reaction, your catalyst remains. A catalyst will speed up a reaction rate, and it does this by making the correct types of collisions more likely.